Today, we are going to discuss about the numericals in Newton's laws of motion. Okay, moving the first one. See here, a body of mass 5 kg traverses in successive seconds the distances s, 8, 9, and 10 meters. Find the force acting on it. What are the distances traveled by the mass given? 8, 9, and 10 meters. In successive seconds, mass of the body is given as 5 kg. Okay. Now, given mass of the body as 5 kg, change in distance what is the change in distance? Difference between two successive distances 8 and 9 or 9 and 10. What is the difference? 1 meter. Okay, and successive seconds he said, that means change in time is 1 second. Okay, we are asked to calculate force now. From Newton's second law, I can write F is equal to ma. Here acceleration is not given. That's the reason why I'm expressing acceleration as change in velocity by time. Okay, change in displacement by time. So I can write it as delta s by t square as acceleration. Okay, that is mass. What is the mass of the body given? 5 kg. Change in distance 1 meter by time square. Okay, you can write it as 1. So how much you are getting? 5 Newton is the force. Therefore, what is the option? The fourth option is correct. Okay. Let us move to the question number 2. The force which is acting on a 1 kg mass develops in it an acceleration of 1 meter per second square in its own direction, given by, say, given mass of the body 1 kg, acceleration how much it is? 1 meter per second square. From Newton's second law, since F is equal to ma, directly you substitute the values. Mass as 1 kg, acceleration as 1 meter per second square. Okay, so 1 Newton, where Newton is the SI unit of force, because this mass and acceleration, they both are in SI system, 1 kg or MK system, 1 meter per second square, unit of acceleration in SI system. So the unit of force in a system is 1 Newton. Okay. Next one. A body of mass 50 grams is allowed to fall freely under gravity. Calculate its momentum after 5 seconds. In this problem, acceleration due to gravity, you are asked to take it as 980 centimeter per second square, CGS system. See, all are in CJ system only. Grams is in CJ system. The mass, time is of course 5 seconds. G value is 980 centimeter per second square. So, given, write down, mass as 50 grams. Time as 5 seconds. The value of G you are asked to take it as 980 centimeter per second square. We want momentum you are asked to calculate. Momentum. We know that momentum is nothing but the product of mass and velocity. In this problem, mass of the body is given as 50 grams. So, in order to calculate momentum, we want velocity. So, according to the given information, let us calculate the velocity. After getting velocity, we can get momentum of the body. Okay. Now, he said that the body is falling freely. The body is falling freely under the influence of gravity. As the body is a freely falling body, in order to calculate velocity, let us use first equation of motion. What is first equation of motion? V is equal to U plus AT. We know that for a freely falling body, initial velocity of the body is 0 and A is equal to plus G, right? You apply this in this equation and find the velocity. V is equal to 0 plus G into T. That is 0 plus G is how much? 980 into time is 5 seconds. Okay. This is 4,900 centimeter per second. I got velocity. As I got velocity, as I am given the mass of the body, our requirement momentum can be calculated as, see here, momentum P is nothing but mass into velocity. Okay, children. What is mass of the body given? 50 grams. Multiplied by velocity, how much we got? 4,900. If you simplify this, you are going to get the momentum as 245 times 10 power 3 CGS units. Okay. So, the option fourth one is correct. Okay. Next question, please. A player kicks a 0.5 kg football and gives it a velocity 10 meter per second from rest. The contact between force and ball lasts for 1/50 seconds. What is the force of impact? See, this is based on change in momentum. These problems based on the change in momentum is very, very important from Eamcet point of view. From Newton's laws, the problems based on change in momentum or impulse, they are very, very important. This is a problem based on that concept. See here, a player kicks a ball of mass of the ball is 0.5 kg and gives it a velocity 10 meter per second. Gives it a velocity 10 meter per second starting from rest. He said that starting from rest. So, initial velocity must be 0. What is final velocity given? 10 meter per second. The contact force lasts for 150 of second. One by 50 second. Okay. The force of impact. Force of impact you are asked to calculate. Okay. See here. From Newton's second law, we know that F is equal to ma. Here we don't have acceleration, but the time is given. Final velocity is given. Initial velocity is 0 because the ball starts from rest. So let us try to express acceleration in terms of velocity and time. Okay. So that I can write in place of acceleration, change in velocity by time. Okay. Substitute the values. Mass of the body is 0.5 times velocity. Final velocity is 10. Initial velocity is 0. Time is 1 by 50. Okay. So, this if you simplify, how much you are going to get? This becomes 5 by 10 into 50 into 10. 1 0 you can cancel. So 25 into 10, you are getting 250 newtons. Okay. So, the required force is 250 newtons. So, the option third one is the correct one. Okay. The next question. A hammer with a 500-gram head is used to drive nails horizontally into a wall. A force of 450 Newton required to penetrate the wall. Each blow should force the nails 5 millimeter into the wall. What should be velocity of the hammer to strike the nail? See, a hammer, suppose this is the wall, or suppose this is the nail. A hammer with a head of 500 grams. A hammer with a head of 500 grams. Okay. Is used to drive nail horizontally through a wall. If you hit the nail, this nail will move into the wall horizontally, he is saying. A force of 450 Newton is required. How much force is required? 450 Newton is required to penetrate into the wall. Okay. Through a distance of 5 millimeter. It has to travel a distance of 5 millimeter. Okay. What should be the velocity of the hammer? That means with how much velocity this hammer has to hit the nail so that this nail will move through a distance 5 millimeter into the wall. Okay. That is the question. So, given force is how much? Force as 450 newtons. Okay. Mass is 500 grams. Then after distance, S is 5 millimeter.
So 5 millimeter, it has to be expressed in terms of meter. So 5 10 power minus 3 meters. This is 500 grams. Nothing but 500 10 power minus 3 kg. Okay. Now, let us use the formula F is equal to ma. You are asked to calculate the velocity of the hammer. See, when this hammer is hitting the nail, initially the nail is at rest now. Now, using third equation of motion, v square minus u square is equal to 2as. V square minus 0 is equal to 2 a into s. From this, V is equal to root 2 a into s. Now, from this Newton's second law, can I write acceleration as F by m? Because we don't have acceleration, we want to calculate velocity. So, in place of acceleration, I am substituting force by mass. Okay. So, see here, V is equal to root over 2 into, see, in place of acceleration, I am writing force by mass. Force by mass into distance. Okay. Now substitute the values. V is equal to root over 2 into, what is the force? 450 newtons into distance 5 10 power minus 3 meters by mass. Mass of the body is 500 times 10 power minus 3. Okay. This one, if you simplify, this value is going to be root 9, which is equivalent to 3 meter per second. This is the final answer. So, the option third one is correct. Okay. Next question. A constant force acts for 5 seconds on a body of mass 5 quintals and then ceases to act. During the next 5 seconds, the body describes a distance 100 meters. Find the magnitude of force. Given 1 quintal is equivalent to 100 kg. Okay. What he is saying, a constant force is acting for 5 seconds on a body of mass of 5 quintals and then ceases to act. That means the force has stopped. Act. Here what happens when the force ceases to act. When the force ceases to act, then what happens? The body moves with uniform speed. Okay. When no force is acting, then the body moves with uniform speed. Okay. What is the speed here? Speed is equal to, can I substitute the distance by time? Distance is how much? 100 meters. The time is nothing but 5 seconds given. So how much it is? Is it 20? Okay. So 20 meter per second is velocity. Now, since initial velocity is 0, and the force acts for the next 5 seconds, then acceleration produced is given by, see here, since initial velocity is 0, the force act for 5 seconds using acceleration. A is equal to v minus u by t, change in velocity by time. Final velocity, how much we got? 20 minus initial velocity as it is starting from rest 0, my time is 5. So 20 by 5 is nothing but 4 meter per second square is acceleration of the body. Okay. Therefore, what we are asked to calculate? Find the magnitude of force. So magnitude of force, F is equal to ma from Newton's second law. Okay. What is mass of the body? 5 quintals. So 500 into what is the acceleration we got? 4 meter per second square. So how much? 2000 newtons is the required answer. Okay. 2000 newtons. It is SI unit, not newtons. So the option second one is correct. Okay. Next question. If a force of 15 newtons acts upon a mass of 15 kg, what velocity does it generate in 8 seconds? So, a simple problem. See here, given, first write the data that is given to you, then it gives a complete picture. Okay, it will be easier for you. So, force is how much given? 15 newtons acts on a body of mass 15 kg. Time is given as 8 seconds. What velocity does it generate? Okay. First, is equal to force and mass given now. See here. Since F is equal to ma, as he has given force and mass, by using this formula, first calculate acceleration. So from this I can write A is equal to F by m. Okay. F is nothing but 15 newtons by mass is 15 kg. So the acceleration, I am getting it as 1 meter per second square. Now, as we are asked to calculate the velocity, what I am doing, using V is equal to U plus AT. Okay. Using this V is equal to U plus AT, initially the velocity of the body is 0. So that I can write 0 plus acceleration, how much we got? 1. The time it is given as 8. Okay. So the required velocity is 8 meter per second. This is the final answer. So where is option 8? Second one is correct one. Okay. Next question. A stone of mass second. Says a stone of mass 2 kg falls through water with acceleration 3 meter per second square. If g is a 10 meter per second square, what is the resistance of water? Okay. See here. Given mass of the stone is how much? 2 kg. It is moving with the acceleration. How much? 3 meter per second square. The value of g is 10 meter per second square. The resistance force you were asked to calculate. See, a stone, it is dropped in water. A stone is dropped in water. Stone is moving in the opposite direction to the flow of water. The water is flowing like this. The stone you are throwing in this direction. The forces offered by water to the stone, they are opposite. Those we call them as the resistance force. Those resistance forces offered by water on the stone you are asked to calculate. Okay. So, here the resistance is nothing but resistance. Resistance is also force. Force we know M into A, but in this case acceleration is net acceleration we have to take. Okay. Net acceleration means we have to consider the both acceleration of the stone and acceleration of water. Here acceleration of the stone is only 3 meter per second square. Resistance of G, acceleration gravity G, it is given as 10 meter per second square. So G value is more than A here. Due to that reason, the net resistance we have to take it as G minus A. So substitute the values. Mass is 2, G is 10 minus acceleration is 3. That is 2 into 10 minus 3 is 7. So the required force is 2 sevens are 14 newtons is the required answer. The option is first one. Okay. Next problem. A cricket ball of mass 100 grams moving with the velocity 12 meter per second and is hit by a bat so that the ball is turned back with velocity 20 meter per second. The force of a blow acts for 0.01 seconds on the ball. Find the average force exerted by the ball on the wall exerted by the bat on the ball. A small correction here, students. It is a ball on ball given. This should be bat. Force exerted by bat on ball. Okay. That small correction I am bringing it to your notice. Remember. Okay. See here. This problem is based on impulse. Impulse. This concept of impulse is very important. Impulse is nothing but the change in momentum. Change in momentum of the body, we call it as impulse. First, let us see the situation here. A cricket ball of mass 100 grams is moving with a velocity 12 meter per second. For example, see here. A cricket ball of mass 100 grams is moving with a speed 12 meter per second. This is initial velocity. Okay. Is hit by a bat so that suppose this ball is hitting the bat here. This is the bat for suppose. Okay. The ball returns back with velocity 20 meter per second. The ball returns with velocity 20 meter per second. Okay. The force of a blow acts for 0.01 seconds. Here, the time of contact of ball with the bat is given as 0.01 seconds. Okay. Find the average force exerted by the bat on the ball. Okay. Now, let us calculate initial momentum of the ball. Initial momentum of a ball. What is momentum? Momentum is nothing but product of mass and velocity. That is the mass of the ball. 100 grams. 100 gram. 1 gram is equal to 10 power minus 3 kg. So 100 grams means 100 into 10 power minus 3 kg into what is velocity given? Initial velocity 12. Okay. So what is initial momentum? 1.2 kg meter per second. That is the initial momentum of the ball. Okay. Then final momentum of the ball. To get the final momentum, we have to multiply mass of the ball with the final velocity. Okay. Again, mass of the ball is 100 grams. So 100 10 power minus 3 multiplied by velocity. Final velocity is how much? 20 meter per second into 20. Okay. So its value is going to be 2.0 kg meter per second. Right. Now, change in momentum. Change in momentum. This concept is very important, children. Change in momentum. To get the change in momentum, what we have to do? Initial momentum minus a final momentum. Okay. Initial momentum is 1.2 minus final momentum. I am writing it as minus 2.0. Why I am writing 2.0? Because after ball strikes the bat, the ball is moving in opposite direction. No, this is the initial direction. After striking, it is moving in opposite direction. That's the reason why this velocity I have taken with the negative sign. Okay. So how much this value is going to be? 1 plus 2, 1.2 plus 2. Its value is 3.2 kg meter per second. Okay. A change in momentum. We know that average force. Average force is nothing but change in momentum by time. The value of change in momentum, how much we got? 3.2 by time of contact is how much given? 0.01 seconds. Okay, this one if you simplify, you are going to get the required average force as 320 newtons. So where is 320? Yeah, second option. The second option is correct one. Okay. Next question. While waiting in a car at a stoplight, an 80 kg man and his car are suddenly accelerated to a speed of 5 meters per second as a result of rear end collision. The time of impact is 0.04 seconds. Find the average force of the man. See, given what is mass of the man? 80 kg. He suddenly accelerates to a speed 5 meters per second he has given. Suddenly accelerates. Means initially it is at rest now. Initially at rest, so initial velocity is 0, final velocity is given as 5 meters per second. What is the time given? 0.04 seconds given. You are asked to calculate average force. Again, from Newton's second law, F is equal to ma, mass into express acceleration in terms of velocity and time as v minus u by t. Substitute the values. Mass is 80, v is given as 5 minus initial velocity is 0 by time is 0.04. This is how much? 80 into 5 into 100 by 4. Okay, 4 goes here, 20. This one if you simplify, you are going to get the answer as 100 into 10. How much? Point okay, 10,000 newtons. 10,000 newtons. See here, students, all of you, there is a small printing mistake in the question. Here, the time it is not a 0.04. Its value is just 0.4, not a 0.04. This is 0.4. If it is 0.4, then this answer, fourth option you are getting. There is a small printing mistake in the question. The time is given as 0.04. No, that is not 0.04, 0.4. If it is 0.4, then we are getting the fourth option. Okay. So, just make the small adjustment there in the question. So, here, small corrections I am making here. See here, time is 0.4 seconds. See here carefully. This is 0.4. Okay. To 5 into 1 0 you can remove. Okay. Now it will be clear. You are getting 1000 newtons as the answer. The option is fourth one is correct. Just make the small adjustment there. Time is 0.4, not 0.04. Okay. Then we can move to the next question. Eleventh one. The driver of a car moving at a speed 20 meters per second sees a child standing in the middle of the road. He immediately applied brakes to bring the car to rest in just 5 seconds to save the child. If the mass of the car is given as 940 kg, with the mass of the driver as 60 kg, what is the magnitude of the retarding force of the vehicle? As he applied the brakes, what happens? The car moves with decrease in velocity. That is, we call it as retardation or deceleration. The velocity of the car gradually decreases. Okay, that's the reason why we call the magnitude of the force as retarding force. Your magnitude of the force gradually decreases. Okay, see here. A car moving at 20 meters per second sees a child in the middle of the road. Okay. Given initial velocity is 20 meters per second. The car finally stops now. That means the final velocity of the car will be 0. Okay. Immediately applies the brakes in 5 seconds. Time is 5 seconds. Mass of the car is 940 and mass of the driver is 60. So what is the total mass here? Total mass. How much? Mass of the car plus mass of the driver. Mass of the car is 940, driver is 60. So the total mass is 1000 kg. Okay. The magnitude of the retarding force you are asked to calculate. See, it's very simple. We have to apply F is equal to ma. Mass is, we know, 1000. What we want? We want acceleration to find the force. In order to get acceleration, we are having initial velocity, final velocity and time. Okay. So, since A is equal to V minus U by T, okay, V is 0 na, minus initial velocity is 20, time is 5 seconds. So what is the acceleration now? Acceleration is minus 4 meter per second square. Okay. Then apply the formula. F is equal to ma. So mass is how much we got? 1000 into minus 4, that is minus 4000 newtons. Here negative sign for retarding force. I told you already, retarding force is nothing but the force which opposes the motion is called retarding force. So its sign need not be taken into consideration. We are asked to calculate only magnitude of the force. Magnitude of the force. So don't consider directions. 4000 is the correct answer. Where is the 4000? Here. 4000. So the option fourth one is correct one. Okay.